now, how about that 70s funk coming at ya? All right, guys, I will need you to open up your workbook to page 19, please, and get ready to take some notes as we work our way through a few examples. So at this point, you've learned a whole bunch of stuff about connector words like and, or, not. You have learned about symbols that we can use when we're describing sets or comparing sets. And then in our own little lessons, aside from the workbook, we've learned how to make a Venn diagram and how to interpret a Venn diagram. And what we're doing in lesson 3, which, by the way, will take us 2 days to get through, is putting all of that together. Back in lesson 2, we learned that when it comes to a set of elements, and for us from now on, it's usually going to be a set of numbers, but not always, I guess. But when it comes to a set of elements, in lesson 2, we learned that we could use the curly brackets and we could describe the set by listing the elements. We could also describe it using words. And we could describe it using set builder notation, which is the least common. And then now we're getting into how we can display or describe sets of numbers and how they're related using a Venn diagram. So kind of putting it all together. All right, we are going to start here with this review question. So it says, the following is taken from class exercise number 2 of the last lesson. Consider the following 2 sets, subsets of the universal set of natural numbers less than 20. So one of the things I think makes our life a little bit easier is if we can see all of the sets. I see here that they describe set A in words and set B in words. Might be easiest if we actually listed the elements. So natural numbers less than 20 that are divisible by 3. So that would be 3, 6. Oh, you know what? I'm just looking ahead here and they are going to ask us to do that. So even if they didn't ask us, I would always start with that list. So I guess we don't need to do this twice. Let me erase. And let's take a look down here at question A. So use the appropriate notation. List the sets of whole numbers less than 20 that are divisible by 3. So for set A, we would have 3, 6, 9, 12, 15, and 18. And let's put for B down here, divisible by 5, which up here is called set B. Capital letter for naming a set. Divisible by 5 would be 5, 10, 15. And now divisible by 3 and 5. And I just want to remind you what that would look like with symbols. That would be A intersect B, because divisible by 3 is set A, divisible by 5 is set B, and means intersect. And so I'm looking for the numbers that belong to both set A and set B. Pardon me, I need to answer the door. Oh, well, that was the FedEx man. My daughter has a serious online shopping problem. All right, back to it. I am looking for numbers that belong to both set A and set B. So the only number that belongs to both is 15. And that's the set that we would be looking at. And then for D, divisible by 3 or 5. So divisible by 3 is set A, or is union, and it's also the one that we think of as adding. So I'm looking for A union B, where I'm adding everything together, combining these to make one big set. So let's start with everything from A. So I'm just going through with A. I'm going to write down everything that I see in A. 3, 6, 9, 12, 15, 18, and keep on going. Our B's, I'll put in a 5, a 10, and 15 is already there. So 5, 10, I've already got the 15. And there we go. All right, so just a little refresher on Venn diagrams. We're going to look at this diagram to the right, and it says relationships between set A, set B, and the universal set U can be illustrated visually in a Venn diagram. So sometimes when we look at the Venn diagram, we only think that there's two sets there because there's two circles. But remember that the one set is everything that's in there. So the universal set is everything that's in the rectangle. Now we've got set A, which is everything in the red circle, including that 15. That is a subset of the universal set. And we've got set B, everything in the blue circle, which is also a subset of the universal set. Says the elements of each set are marked with a dot to distinguish them from the number of elements in each set. So when you see this 10 with the dot, it means 10 is an element. It doesn't mean that there are 10 elements. The other way to look at it is if you see more than one number in a section, automatically those are elements, and that those numbers do not represent the number of elements. All right, so it says the number divisible. So these are still the same set we were just working with in our review. The number divisible by 3 and 5 is located in this overlap. So in the red circle, we have all the numbers divisible by 3. That's our set A. In the blue circle, we have all the numbers divisible by 5. And the overlap, this 15, belongs to both sets. So it is divisible by 3 and by 5. The numbers divisible by 3 or 5 are located within both circles. So remember that or means add. We're adding both of these sets together. And so when we look at when we're looking at A or B, it'd be every single number that is in both circles, putting both circles together. And the number in the universal set that are not in set A or set B are located within the rectangle but outside the two circles. So these are the elements that are part of the universal set but do not belong to A or B. In example 1, what we're looking at here is shading in an area that's been represented or that's been described. So it says in each of the following Venn diagrams, shade the region representing the given set. So in A, it says the intersection of two sets, which could also be called set A and B. And I want you to also see it. They've given it here with words, but let's write it down below with symbols. We need to know both. So A and B would be A intersection B. And let's shade in the overlap region. That's where we would put an element if it belonged to A and B. And the next one, the union of two sets. So with words, we'd say A or B, and with symbols, this is how A union B would look. So if I had an element that belonged to A or B, and that's all I told you, well, you could put that element here or here or here. It's not really clear where it would go. But if it's A or B, it's like we're adding those two sections together. So everything in the circle, both circles, represents A or B. And the next one, the complement of set A. Now with words, we say the set not A. And with symbols, we use that little apostrophe. So I'm going to shade in everything that is not A. So everything that's on the outside of circle A is the complement of A. All right, so we're going to be doing quite a bit of shading in the next few examples, and in some cases, we'll be shading two different sets. So I find that two different colored pencil crayons work really well, or you could use a blue pen and a red pen. But if you're doing that, make sure you're very careful that you know that you're shading in the right region. Don't go ahead and shade something incorrectly that you can't erase. The other thing you can do if you're shading two different regions is you can shade one set in one direction and you can shade the other set in a different direction to show the two different sets. I'm going to use a highlighter, so that's another thing you could do is use a highlighter as well. So we want to see the two different kinds of shading, but we also want to be able to see where do those two different kinds of shading overlap. So let's just take a look here before we get into all this shading. Remember that intersection and the symbol for intersection is kind of looks like an N. What we'll do for intersection is we'll be looking at the overlap. So if we have, and this is not just talking about overlap of two circles, but the overlap of two sets. So we'll shade the two sets differently, and where they overlap will be the intersection. And our connector word for this one is the word and. And when it comes to union, our symbol is that U shape. not to be confused with just a regular U that's used for the universal set. So this is where we would add the two sections together. We'll say the two sets together. So hit pause and run and get your shading devices, either two colors of pencil crayon, two different highlighters if you have them, and then come on back and you'll see what it is we're working with. So in example 2, we're still working with the same sets that we have been so far today. So if you look at the entire rectangle, the numbers that are inside this rectangle, including the ones in the circles, so all the numbers in the rectangle here are the natural numbers less than 20. And we have set A, which we've been dealing with, numbers divisible by 3, and set B, numbers divisible by 5. It says lightly shade the region representing the given set. Describe each set in terms of A and or B using connecting words where appropriate. Determine the number of elements in the set. Some of the work has been completed as a guide. All right, so this first one, it says up here we're going to shade set A. So choose what you'll use. We're only doing one set, so you only need one kind of shading here. So set A is everything inside of this circle. So there's my shading for set A. And you'll see down below here, they've already done the other two for us. So this is the describing the shaded area using proper notation. And then down here, our third piece is the number of elements. So when we do our shading, we want to do it so we can still see what's behind the shading. So in set A, there's 1, 2, 3, 4, 5, 6 elements. And so for this one, we say 6. Okay, so 3 things that we need to do. All right, so you could easily, I think, do the shading on this next one. So if you want to hit pause and give it a try, you are going to shade set B. And then down below, you're going to give the notation for this shaded area, and you're going to talk about the number of elements in that region. So shading set B means we're shading everything inside of that circle. And for notation, all we would use is a capital B for that area. And the number of elements in B is 1, 2, 3. So it seems pretty easy so far. In fact, you might even be saying, oh my gosh, why are we going through this? But it is going to get much more difficult as we go on. So we're trying to build some building blocks here. And also this whole idea of shading the region is teaching us where to look for certain sets. So when we get into some tougher ones, I'll talk to you about that again, is the shading is really teaching us where to look for certain sets. Okay, so here we're going to shade set complement A. So here it actually, the workbook has a little mistake. It's giving us the same thing that they've already given here. Let's put this in words. So if we describe it with words, it would be not A. I'm going to go ahead with that shading. I'm shading everything that is not in circle A. And then down below, we're wanting the number of elements. So if I go and I count the elements in that shaded region, there are 13 elements. Again, you could definitely hit pause here and try the next one on your own. So this one says to shade set complement B. So that means everything that is not in B. I think if anybody was having problems with the complement, the Venn diagrams actually really do help to sort of let you actually see what we mean by complement. So describing with words, I would say not B is what we've shaded. And the number of elements in the complement of B, counting carefully, everything in that blue region, there are 16 elements there. Okay, this time we are shading the set A intersect B. So you might want to think about this with words. Where do you put the elements that belong to A and B? And they would go right here. This overlap section is a section that belongs to both circles. And so when we say how many elements, 15 is the only element in there. So there is one element there. Now union can be a little trickier. Here we're doing the union of A and B. So just remember that union is kind of like adding. So if I want the union of A and B, I want everything that's in A and B. So this shaded region would be the union of A and B. And when we put that with words, the connector word is or, A or B. So every element that we see in that blue region belongs to A or B or both, because in math, or is inclusive. And number of elements in A union B, I go through and I count them and I see there are 8 elements in that blue region. Okay, here's where things are going to get a little more complicated. I want to demonstrate this intersection for you because this, as we're getting more complicated, sometimes it's a little trickier to find the intersection. So notice we're trying to find the intersection between the complement of A and B. So remember earlier we said intersection, think of it as overlap. So I want you to watch this one first before you decide to do anything, because if you start the way I do, you might have to do some erasing. So what we do is we look at the complement of A. So that's everything that's on the outside of A. So I use one kind of shading. Now I'm going to be able to erase this, so I don't have to worry too much about it. But you have to make sure you shade pretty lightly, because in this type of work, we're actually going to have to do some erasing. So there's the first region, not A. The second region is B. I'm going to shade with a different color here. So now I'm going to shade B. So I've got the two regions shaded right now. And because I'm looking at intersection, I want to keep the part where the two regions overlap. So that means I have to go in there and do some erasing now. So the overlap part is the only part I'm going to keep. Well, that erased a little weird, so hang on so maybe I don't. Oh, darn it. Well, you know what? I did enough to see it. Even though this doesn't really erase the way I want it to, I did see that this is where the overlap was. So it's about, for intersection, shade both regions, either different color or different direction, very lightly, and your answer is the part where they overlap. All right, so for this one, if I describe this with words, it would be not A and B. And number of elements in A complement intersect B. 5 and 10 are the only elements in there, so there are 2 elements. All right, so since we're talking about intersect right now and how to shade for intersect, we're going to actually move down to this next example. So again, we're doing intersection. We have these 2 individual regions. We will shade each region a different color or a different direction very lightly. And the intersection is the spots where they overlap. Okay, so let's give this a try again. So I will start with not A. So that's everything that is not in the A circle. So there's our first region. And now I'll do not B. And maybe you can already visualize it. Maybe you don't need to use the 2 kinds of shading. So here goes not B. It's everything that is not in circle B. Now, as you're doing this, remember that we're looking for where do the blue and the pink overlap. So if I was erasing like a normal eraser right now, I would be erasing this part in here because there's no overlap there. And I would erase this part because there's no overlap in there. And so the only part that would actually keep in our answer, or where the intersection is only where we have the overlap. So our final answer, our final shading, is going to be on the outside of both circles. So I was going to remind you that this whole idea of shading is telling us where would we look to find this given set of numbers. So understanding this whole shading thing is going to help us later when we're doing questions where it just says, how many elements are in here? We have to know where to look for it. So let's describe this with words. So not A and not B. Now, to me, when I'm doing intersection, I think the words describe what you're looking for. So if we can take this expression and we can write it as words, then finding the region is not bad at all. You think to yourself, where would I put an element if it was not A and not B? It would have to go out here in this pink region. And if we look at the one above, if I had an element and it was not A and it is B, this pink area is where I would put it. So doing an intersection, if you put it into words first, that will help you to figure out what part of the diagram we're looking at. And here with the number of elements, I go and I count them up. There are 11 elements in the pink region. Now, to me, union, I don't know that the words really make a whole lot of sense for the union, but if you just remember that you're going to add these two together, I'm going to shade this region, I'm going to shade this region, and I'm going to keep all of the shaded parts. There's no erasing here when we do our shading. And I can use one kind of shading. I don't need two colors or two directions or anything like that. So I'm going to shade A. Everything in the circle is A. And I'm going to shade not B. So everything on the outside of B. Remember, these two sets, A and not B, are being added together or combined into one big set. So I don't have to erase, I don't look for overlap. I just shade the two regions and I keep it all. So with words, we would say A or not B. So with words, I don't think it really makes it easier to understand. And number of elements in A union, complement of B. I'm going to count all the elements in that pink region and it comes to 17. And then our last one, again, is a union question. So remember, just think add. I'm going to shade the complement of A and shade the complement of B all with the same color and keep it all because I'm making one big region or one big set from those two sets, combining them together. So not A is everything on the outside of A. And not B, that's everything on the outside of B. So the whole blue region, we keep it all because we're putting those two together to make a larger set. With words, it's not A or not B. And I'm looking for the number of elements. And it comes out to be 18 elements in that region. Okay, and then these last two, starting again, gets a little tricky in here, but if you just keep thinking about our rules for shading. So intersection, you can either use the words to figure it out, or you can shade the region and then get where they intersect. And for union, shade them both and keep them. Now what gets tricky here is that we are dealing with the complement. So I'm first going to find that intersection, and that intersection is actually fairly easy to find. A intersect B is right there. So the complement of A intersect B is everything except that region that I have shaded in. So we're looking for the area that is not A intersect B. So we're going to shade in everything except that intersection. And so that's the one that we're talking about here. Okay, with words, it would be not A and B. So again, to me, the words make sense. If I think about it's not A and B, that means it has to be everything except A and B. So I think about where would I put something if it belonged to A and B? And I shade everything except that region. The number of elements is 18. And then our last one here, again, think about where this section would be. So A union B, don't shade where I'm shading, I just want to show you. A union B is everything in the circles. And so we want the complement of A union B. So we want everything that is not in this shaded region. So everything that is on the outside of the circle. Or I should say on the outside of both circles. So they've got with words not A or B. And number of elements is 11. Now I want you to notice that we have to have brackets when we're doing this description with words. Right there and right there. If I didn't have the brackets, let's say I had, and again, don't write this, but let's say I had not A or B, that would have a different meaning. That would be complement of A union B, which is different than what we're working at right there. So make sure that you understand the brackets are important on that one. Okay, and your workbook just takes a moment here and it sort of, I guess, is telling you, notice that in some of the questions that we did, the shading was actually the same. So if you go back and look at some of the shading, this set and this set are actually identical. This set and this set are actually identical. And it might make your work easier if you remember that. But to me, it can be a little bit tricky to remember, so I wouldn't worry about it too much. All right, so on page 22, an excellent question to make sure that we've really got it. So this is that idea of like, where would you shade to find this region? And that's where you will find your answer. So it says, use the Venn diagram to list the elements of the following sets. So we're actually going to list the individual elements. So for set P, and again, this is a great one if you're working with a pencil. This is a great one if you want to pause and see how many of these can you get on your own without having to guess. So set P is everything in this circle P. And don't worry too much about getting them in the right order. And I know I'm going to write too big, so I'm just going to make some space below here. So it would include 1, 2, 8, 9, 10. That would be set P, everything that's in circle P. Set Q, let's move our circle over. There we go. Set Q, we're looking at everything that is in the blue circle is set Q. So set Q, remember curly brackets would be 1, 7, 10, 29. P and Q. So if you had an element that belonged to P and Q, you'd have to put it here. So that set would include elements 1 and 10. P or Q, remember where we shaded, P or Q is when you put the two together to make one big set. So everything inside the circles would be part of P or Q. So that is 1, 2, 8. Whoops, I'm out of order. Remember, your order doesn't really matter. I was trying, but I got my order out of order. So 1, 2, 8, 7, 9, 10, 29. Whoops, curly bracket. So just a reminder that sometimes these same questions will be given with symbols. So this question with symbols would have been P intersect Q. This one with symbols would have been P union Q. So we have to understand both symbols and words. Okay, not P. Oh, let's get rid of our shading here. So not P means I am taking everything that is not in circle P. So it's going to be 11, 16, 7, and 29. Those are the ones that are not in P. Your order, again, doesn't really matter. 7, 11, 16, 29. Not Q. Is everything that is not in Q. So that would be 16, 8, 9, 2, and 11. Those are all the elements that are not in Q. Okay, and remember with symbols, not P would be the complement of P, and not Q would be the complement of Q. All right, let's go on to G. So getting a little trickier as we work our way through this one. So not P and not Q. Let's look at that one with symbols first. So not P and not Q. So this is an intersection question. So you might do our shading that we did. Don't do any writing right now. I just want to show you your options as we get to these trickier ones. So I could do my shading. So I could shade in not P. And I could shade in the not Q. And remember, for intersection, we would only be keeping the overlapping region. And that's where we would look to get our answer. And the other way, when it's intersection, the other way is to use the words and think about, what do the words tell you? So you may just want to think about the words that they've given us. If you had an element that was not in P and it was not in Q, where would you put it in the diagram? So the 16 and the 11, those are the numbers that are not P and not Q. So maybe it's easier to think about intersection with words. And then this time we've got not P or, so union, not Q. So if I was doing this with symbols, not P is complement of P, or is union. Not Q is complement of Q. And with union, the easiest way to figure out where you're looking or where you're shading is to remember you're adding those two sections together. So if I was using shading, I would shade everything that is not P. I would shade everything that is not Q. And because I'm adding these two regions together, I would keep it all the same color to make one big region. And everything in that shaded region would be part of this new set. So for H, we'd say 2, 7, 8, 9, 11, 16, and 29. Now, this one, because of the brackets, you really have to be careful here in I to make sure you understand why the brackets are there. We have to figure out where this section is, and then we apply the not to it. So let me erase here while you're thinking about this next one. So if I was looking at just the part in the brackets, P or Q, that would be everything that's in the circles. So I want the complement. I want the stuff that is not inside the circles. And that is 11 and 16. So again, we actually see that I and G are the same thing. And again, with J, make sure you understand the brackets. Find that section first. So P and Q, remember that's the overlap. So we want the stuff that is not P and Q. So everything except where I have that blue shaded region, which is 2, 7, 8, 9, 11, 16, and 29. So again, we see it's actually the same thing as H. These sets can actually be described in different ways. So again, if I went back up to the bottom of page 21, I would see it written there. This will be a good time let's just look at our symbols again. So for I, if I was doing not P or Q, I'd have to put the P or Q in brackets and the not on the outside. And for J, P and Q in brackets, so P intersect Q and the not on the outside. So with symbols, what I see is that G, which is not P, intersect not Q, is actually the same thing as I, which is P union Q, the complement. And H and J are also the same. So the reason I said it might be easier, might make your life easier if you remember these are the same, and you might have noticed here, I thought that I was easier to figure out than G. So if I know that they're the same, I can just always think of it in terms of I. We could do the same thing with H and J. I found J was easier to figure out than H. So if they're actually the same thing, whenever I see something like H, I could just think of it in terms of J. But it is extra to remember it, and so maybe it makes it harder to actually do that remembering. All right, we're on our last example here. I want you to pause and give this one a try. So when we see this diagram where we have just single numbers, this is now telling us that's how many elements are in that set. So we don't get to see what the elements are, but we just get to see how many elements belong in that position. So feel free to pause and give it a try if you're feeling confident. So we'll start right here. The diagram displays the number of students who are members of student council. So student council, we're using an S. So here's the circle for student council. And the number of students who are on the yearbook committee, Y. So in this circle, we've got the students on the yearbook committee. All right, ready to answer some questions. How many students are on student council? So everybody in this circle is on student council. So I'm going to add them up, 12 plus 3. There are 15 students on city council. And if you don't look at that and say, oh yeah, I know where that came from, you might want to just remind yourself we had to do the 12 plus the 3. And how many students are on both student council and yearbook committee? So everybody in this circle is student council. Everyone in this circle is yearbook committee. Notice that this 3 is in both circles. And so we would say that there are 3. And part C, how many students are on the yearbook committee, but not on students council? So these 7 people right here, they're in the yearbook circle, but they are not in the student council circle. So we've got 7 people. And D, how many students are on student council or yearbook committee? So when we see or, we should be thinking add. So or is everything that's inside the circles. We add it all up. 12 plus 3 is 15, plus 7 is 22 people. All right, sorry guys, this was a long one, but tomorrow you're going to get a short one. Your practice work, even though it was a long lesson, your practice work is not very long. It's just page 23, numbers 1 to 4. Make sure you're checking your answers. The answer key is attached to today's material. And remember to ask questions if you have them. You can email or put your questions on my question form. Have a great day, everybody. Stay healthy and take care of each other.